Kia ora koutou. This is question 4 in tomorrow morning's scholarship calculus session. So I'm hoping that no one is watching this at the moment who's planning on going to the 7:30 session. Obviously you're going to get more out of it, I think, if you're there in person, but this is for people who are away with COVID and self-isolating and just really tired out from lots of internals and stuff. So this question is one where if you do a good diagram, you'll see what to do. If you don't do a good diagram, I think it's quite hard to get there algebraically, and it's a locus problem. So what we're looking for is if this is true and this is true, then we have to show that this is true. So what is the this? Well, the this is the magnitude of the complex number. So, for example, if I've got a point out here, z, then the magnitude is the length of that line. So we're saying for all of the points that have got a distance between the origin and that point of less than or equal to 4, and this condition here, then we have to show that this is true. Now, when I've been teaching this to my A-level class, I've really stressed that in level 3 NCEA, it's important to do full algebraic working when you're doing locus problems. And that's from experience with people getting dinged where they went straight to a geometric solution. In this case, I'm going to do the geometric bit first, and then we'll work backwards and do the algebra. This is simply saying the distance from the origin has to be less than or equal to 4. Now, I've got a nice graph done in another slide or two, but just doing this one here, here's what I've got here. This is a very simple locus. It's a circle. It's the equation of a circle. So the distance from the origin has to be 4 or less. You can see that what we're going to draw there, let me try and do it properly with a circle. Is that going to work? Oh yeah, look, that's going to work, kind of. Let's center that circle on the origin and let's make it a bit bigger. Yeah, kind of. Oh, look, there we are. That'll do. Okay, so that's my first locus. And we want, to satisfy this locus, we want to be inside that circle. So let's color that in with the yellow. So we're going to have two conditions. That's my first one. Now this one here is also going to be a circle with a radius of 4, but we can rewrite this as z minus 4 plus 4i, and hopefully if you're in level 3 calc classes, that should be getting pretty familiar. This is going to be the locus of a circle with a center here and a radius also of 4. So what do I know about kind of how that fits with the first one? Well, let's do it properly and line it up. So we've got the center at 4 plus 4i, and the radius is going to go out 4. So this point here is going to be on the edge of this circle, and this one here. And now we're going to go up here and out here. So we've got two intersecting circles. Now we're drawing a very bad, oh, what a bad circle. Oh no. Okay. Hopefully Mr. Vaughan's not watching. He would not be happy with that circle. So now to satisfy this locus, we need to be inside the green shaded bit. Okay, it's kind of like colouring in with crayons. So the bit that we want, the set of points that we want are the ones that satisfy both of those things. That means that we're looking at this overlapping area in here. And we have to show that for any point in that overlapping area there, that the magnitude is greater than or equal to this thing here. So let's take a ruler and see what is the smallest distance from the origin that we're going to have there. Well, you can see, and it is worth doing this with your ruler so you convince yourself what's going on. You can see that here, it's going to be somewhere on this edge of the circle, right, is going to be the shortest, the minimum distance point. And it's not going to be up there. It's going to be on the line between the origin and the center of that other circle. Let's see if I can draw that in, right? So we're going to be on that line. What we're looking for is to find this distance here, and we need to show that it's equal to 4 times root 2 minus 1. So now we're going to go back and we're going to put in some algebra so that we can figure out what that point is. So there are a couple of ways to do this last bit, and I've just realized that the way that I've done it is quite a slow and stupid way. But let's just start off with some circle equations. So the first circle, the one that's got the yellow in it, has got equation x squared plus y squared is equal to 16. The second circle out here is going to have the centre at 4, 4, so it's going to be x minus 4 squared plus y minus 4 squared is equal to 4 squared, which is 16. We are looking for the point here, which is on both the circles. So I'm going to erase some of this. Let's just clean that up a bit. The point that I'm looking for, I'm going to label point A. Right, so what do I know about point A? Well, point A is on this line here. So it's the line that's going through the origin and 4, 4. We can see from that the line is going to have equation y is equal to x. So the point that I'm after is on this second circle, this one here, and y is equal to x. So I can find the coordinates of point A. We've got x minus 4 squared plus x minus 4 squared, substituting in that, is equal to 16. 2 times x minus 4 squared is equal to 16. X minus 4 squared is 8, giving me x is equal to 4 plus or minus root 8, which I'm going to rewrite as 2 root 2. Now, which of those values do we want here? Well, let's just see where they are. We've got x is equal to 4 minus 2 root 2, and x is equal to 4 plus 2 root 2. Sometimes we'll want this further away one, but for now, we want this point down here. Okay, so this x coordinate here. Okay, the distance that we're after here, I could do even without finding that point, and I've just realized that I've just done all this extra work and I don't need to do it. And probably someone's going to leave me a comment saying that in the video, so I thought I'd say that now. Look, all we need to do is this. The minimum distance is going to be the distance from here to here. Oh, why is it not working? Something's gone wrong with the pen. Okay. I think the computer wants to shut down for the night too, just like me. Right, there's the distance there. We know that distance, right? That distance we can get using Pythagoras. So this whole distance here from 0 out to point X has got 4 here and 4 here. By Pythagoras, OX will equal the square root of 32, which is equal to 2 times 16, which is equal to 4 root 2. So OX is equal to 4 root 2. And then what do I know about OA? Well, I don't know directly about OA, and that's why I was going down this pathway here, which is totally unnecessary. But what I know about AX is that it's the radius of that circle, which is of length 4. So we know that OA is equal to OX minus 4, since it's a radius. So length OA is equal to 4 root 2 minus 4, which is equal to 4 into root 2 minus 1. And if you go all the way back to the start of the question, that's what we had to show here. So we had to show that the minimum distance to be in that locus, which has gone now. All right, so the locus that we want is the overlap of those two, and the minimum distance is going to happen at this point here, and that's going to be this whole distance here, which is length 4 root 2, minus this radius distance here, which is just 4. Okay, when I do that in class, I'm going to write that up with a little bit more algebra, and I'm also going to step through how we do showing these equations, because when I've looked at marking schedules for level 3, it has needed you to start off by going let z equal x plus iy. Now, to me, that feels like a bit much, because by the time you're working at scholarship level, it should be pretty obvious that this is the locus of a circle. Okay, so I think for scholarship, my gut says it's fine to do it geometrically, but for level 3, we're going to go back and we're going to go slowly through all of this reasoning here. And if you're watching this and you're doing Cambridge A level, it's fine for these questions to go directly to a geometric interpretation. All right, thanks for watching. I'm not going to do the other 2 questions tonight, but I'll try and do them over Friday or Saturday or Sunday.